Hi there. What is happening weather-wise? We are looking at a phenomenon known as a sudden stratospheric warming, which is going to occur very soon. This weekend, in fact, the warming and vortex split will occur. So what is it, and what are the implications for weather on our shores in the UK? So every winter the stratosphere cools down dramatically as less solar UV radiation is absorbed by the ozone content in the stratosphere. The increasing difference in the temperature between the North Pole and the latitudes further south creates a strong vortex, the wintertime stratospheric polar vortex. The colder the polar stratosphere in relation to the mid-latitudes, the stronger this vortex becomes. The stratospheric vortex has a strong relationship with the tropospheric vortex below. A strong stratospheric vortex will lead to a strong tropospheric vortex. This relationship is independent. Conditions in the stratosphere will influence the troposphere, while tropospheric atmosphere and wave conditions will influence the stratospheric state. At the surface, the strength and position of the tropospheric vortex influences the type of weather that we are likely to experience. A strong polar vortex is more likely to herald a positive Arctic oscillation, with the resultant jet stream track bringing warmer and wet southwesterly winds, like we experience most winters. A weaker polar vortex can contribute to a negative Arctic oscillation, with the resultant mild weather tracking further south and more blocked patterns the result. A negative Arctic oscillation will lead to a greater chance of colder air spreading to latitudes further south, such as the UK. The stratosphere is a far more stable environment than the troposphere below it. However, the state of the stratosphere can be influenced by a number of factors: the current solar state, the quasi-Bennial oscillation, the ozone content and distribution and transport mechanism, the snow cover and extent indices, and the ENSO state, to name the most significant. ENSO state being El Nino or La Nina. This year we are currently in a La Nina state, although reducing all the time. These factors can influence whether large tropospheric waves that can be deflected into the stratosphere can disrupt the stratospheric polar vortex to such an extent that it feeds back into the troposphere. Essentially, the vortex warms up, displaces and splits. And the downward propagation of those cold, very very cold, -80 almost temperatures, hopefully make their way to our shores. And if we get lucky and the precipitation is in the right place, we could have epic snowfall. It's not a guarantee, it's 50-50 at the moment, I would say, but all the experts on Twitter are excited out their underpants. So it's looking good, folks. So what does this say? Well, the next few short clips will show what it looks like. And there's also a nice little video from the BBC guy explaining it probably more clearly than I have, but hopefully this video has been useful. And just to clarify, the -80 temperatures that do downward propagate from the stratosphere, it won't be -80 over our shores. It will be cold, very cold, minus temperatures, but not -80, not as cold as that. It does warm up slightly as it reaches the troposphere and our shores. Okay, hope you enjoyed the video. If you could subscribe to my son and my nephew, that's JJ Jackstar and TT Tailstar, future YouTubers. Well, they're here and now YouTubers, but big stars in the making. Cheers, folks.
This to about 10 kilometres, and it's where most of our weather actually takes place. Above that, we have the stratosphere. Here the air is much thinner, much drier, and there's actually little or no cloud. It's also where we find the ozone layer. Now, during the polar night, the air across the pole or over the top of the pole becomes very, very cold. There's no sunlight to warm it up. And in fact, temperatures in the stratosphere can fall as low as -70 or -80 degrees. Now, around the edge of that cold air, we get a ring of strong westerly winds forming. That's known as the polar night jet. Occasionally, you'll find a disturbance coming up from the troposphere to affect that polar night jet. It makes it wave more, it makes it wobble. And when those wobbles get big enough, they actually start to break, just like waves breaking on a beach. When that happens, the winds weaken and even reverse direction around to an easterly. And once the winds weaken, that allows the cold stratospheric air to collapse downwards in towards the pole. And as it collapses downwards, it compresses and warms rapidly. And that's what we see as sudden stratospheric warming.